Hello students, myself Anandraj, Assistant Professor, Department of Mathematics, Nanda College of Technology. In last lecture we had seen about propositional logic and laws of logic. Now we are going to talk about PCNF and PDNF, inference theory, predicate and quantifiers, and finally introduction to proof. Today the first topic is PCNF and PDNF. PCNF means principal conjunctive normal form and PDNF means principal disjunctive normal form. These are standardized forms of logical expression in propositional and predicate logic. The PCNF means a conjunction of one or more preposition. Each preposition is a disjunction of literals. Literal means proposition or their negations. No preposition contains duplicate literals. No literal is repeated across the preposition. Before learning this, we have to know about min terms and max terms. Yes, min terms means conjunction of one or more preposition. For example, if we have two variables p and q, is the min terms of the two variable is p and q, negation p and q, negation q and p, negation p and negation q. The possible combination of two variables by using conjunction is called the min terms. Similarly for three variables, if we have a three variable p, q and r means p and q and r, p and q and negation r, p and negation q and r. In this way we have to form the min terms for three variables. Next, PDN, max terms. Max term means disjunction of one or more preposition. For example, the max terms of two variable p and q is p r q, negation p r q, p r negation q, negation p r negation q. That is, the possible combination of two variables by using disjunction is called max terms. Similarly, for three variables as well as p q r. P q r means p r q r r, p r negation q r r, p r q r negation r. In this way, you have to form max terms for three variables. Therefore, PCNF is conjunction of max terms. I repeat, PCNF is conjunction of max terms. For example, PRQ and negation PRR. Here, conjunction means PRQ and negation PRR. This is called the PCNF, principal conjunctive normal form. Next, PDNF. PDNF, principal disjunctive normal form, is a disjunction of one or more preposition. Each preposition is a conjunction of literals. No preposition contains duplicate literals. No literal is repeated across preposition, as well as the principal conjunctive normal form. Therefore, principal disjunctive normal form is disjunction of min terms. For example, P and Q are negation P and R. P and Q negation P and R is the min terms. P and Q are negation P and R is the disjunction of min terms, that is PDNF, principal disjunctive normal form. So next we are going to discuss about how to find the PCNF and PDNF. The PCNF and PDNF are finding by two ways. One is using truth table and another is without using truth table. That is using laws of logic. For both methods, we have to follow the following procedure. Eliminate implications and equivalence is the first step. Then second step, move negations inward using De Morgan laws. Third step, distribute conjunctions over disjunctions. Then fourth one, and finally, group proposition and remove duplicates. Okay, what is the uses of PCNF and PDNF? That is, simplifying the complex logical expressions and identifying the tautologies and contradictions, And another one is applying logical rules and theorems. These are all the uses of PCNF and PDNF. Okay, next we are going to see about inference theory. Before started this, you have to know about the premises. A premises is a statement or proposition that is assumed to be true and is used as a basis for reasoning and argumentation. I repeat, premises is a statement or proposition that is assumed to be true. That is called premises. In logics, premises are used to support a conclusion, which is a statement that follows logically from the premises. So clearly states that premises is a statement that is assumed to be true. So inference theory is a branch of logic that deals with the process of drawing conclusion from a premises. It involves the study of inference rules which are used to derive the conclusion from given statements. So that the premises are used to derive the conclusion from a given statement with a certain rules, that is called rules of inference. First one is rule P. A premise may be introduced at any place in the derivation. I repeat, a premise may be introduced at any place in the derivation. It says if you are using given statement means that is rule P. The next one, rule T. A formula S may be introduced in a derivation if S is tautologically implied any one or more of the preceding formula in the derivatives. That says, if you are using any laws of logical implication, that would be rule T. If you are using any laws of logical implication, that would be rule T. Therefore, there are two rules, rule P and rule T. Rule P is you are using a given statement, that is rule P. Then if you are using any formula related to the logical implications, that is called rule T. In this way, we conclude the solution from the given premises. Next, we talk about predicate and quantifiers. Predicates and quantifiers are fundamental concepts in logic and mathematics. Predicates. A predicate is a statement that contains variables and can be either true or false, depending on the values assigned to those variables. Predicates are used to define properties or relations among the objects. So it is nothing but predicate is a statement along with any one of the expressions. It's called predicates. For example, X is a number is a statement, but X is a prime number is a predicate. Ravi is a boy is a statement, but Ravi is a good boy is a predicate. In this way, we have examples P of X. X is a prime number. Q of X. X is a rational number. Here P of X and Q of X is a predicates. The next quantifiers. A certain declarative sentences involves the words that indicates quantity, such as all, some, none, one. Such words indicates quantity. They are called quantifiers. Therefore, quantifiers is nothing but a sentence with quantity. For example, boys are good is a statement. All boys are good is a quantifier because all is mentioned as quantity. Some boys are good, it is also quantifiers. Some is mentioned by quantity. In this way, examples for all x p of x means for all x p of x is true. That is universal quantifiers and existential quantifiers. Here there are two quantifiers. One is universal quantifiers, then existential quantifiers. Existential quantifiers means there exists p of x. Universal quantifier means for all p of x. By combining predicates and quantifiers, we can express complex statements and reason about mathematical structures. Okay, in this lecture we covers uses of PCNF and PDNF, how to find PCNF and PDNF by using various methods, premises, rules of inference, that is rule P and rule T, finally predicate and quantifies. We will see you in the next video. Thank you.